Finally, there is something we must keep in mind here, what is called transient climate response, and that is shown here. The warming with CO2 is not just what is being emitted now, it is the accumulated carbon. So cumulative CO2 emissions and temperature change generally show a near linear relation, which means any additional carbon you put at any time, because of its long residence time and being well mixed, is going to add to the warming as a part of the cumulative carbon. Okay, so this is here showing transient climate response and CO2 radiative saturation being something that will drive it away from this linear relation. CO2 saturation basically is that CO2 has multiple bands in which it's sensitive to the outgoing energy from the surface, the infrared energy, and it's very efficient at 700 nanometers or micrometers, where nanometers or micrometers or microns, and this is the peak emission from the Earth. So it's saturated means it is absorbing all it can at that band, but as you increase CO2, the absorption bands at other frequencies begin to fill up, so the absorption band gets thicker. Nonetheless, the efficiency with which outgoing infrared is absorbed by CO2 begins to reduce as you keep increasing the amount of CO2, and the same works for methane as well. So that's what is driving this deviation away from the linear relation. There are other climate or carbon cycle nonlinearities which can drive in both directions here in terms of carbon climate feedback. So carbon affects temperature, temperature affects vegetation, respiration, photosynthesis, rainfall, which in turn affects carbon, and so on and so forth. And there are permafrost feedbacks where warming is thawing permafrost, releasing methane and CO2. Methane quickly gets burned to carbon monoxide and carbon dioxide and so on, which can increase the rate of warming compared to cumulative CO2. The commitments, CO2 commitments, can go either way and so on. So the effective transient climate response with aerosols and non-CO2 scenarios and so on. This is kind of a schematic from this paper, but the idea is that the near linear relation and its shift in terms of the slope between cumulative CO2 and temperature change has to be kept in mind when we are talking about the future of carbon cycle. And this paper also looks at it in terms of CO2 emissions and where we are in 2020, and then looks at it in 5-year wedges where you track the direction needed for CO2 drawdown to meet the 1.5 degree C budget for 2020 to 2025. And if you have exceeded in terms of the emissions, then you need additional drawdowns. And this is the same thing but for the 2 degree C target, where you're going to hit the net zero emissions. So for 1.5 we have to hit net zero by 2040, and for 2 degree C we have to hit it by 2060. So the amount over budget can be projected, and that has to be included in the nationally determined contributions or any of the geoengineering plans we are making and so on. So this gives you an idea of tracking the budget continuously at 5-year steps, which is reasonable in terms of the adjustment timescales of emitting CO2, biosphere response, ocean response, and accumulation in the atmosphere, and so on and so forth. So the main idea is that the warming has to be kept in mind in terms of its cumulative CO2 impact on warming and how we have to think of drawdown of CO2. And of course we can never forget the idea that the fairness principles in terms of capability, equality and responsibility have to be kept in mind. So the idea of global remaining carbon budget has to be considered with national allocations, with which is now a democratic operation where each country is voluntarily submitting plans, and then the verification, monitoring, and reporting process is supposed to start, I think, in 2023, and already there is talk of submitting revised plans with higher commitments for carbon reduction and so on. And for countries that are trying to grow economically, to carry their citizenry in terms of their vulnerability and resilience, obviously, and impacts, disparate impacts of climate on them, all have to be considered. So that's the final point under carbon for the future. There are lots of details of how equality and gender inequality in the climate impacts and vulnerability and how to help that and so on are discussed in many papers. Obviously, we are not going to go far into that because we are here focused on geoengineering, and we have talked about unintended consequences, but the unintended consequences also should include the impacts on people, especially the global south, which hasn't typically contributed historically to global warming and is already experiencing extremes and other vulnerabilities, and may also end up paying a price for geoengineering experiments done by other countries, which typically may end up being again the rich countries who have been mainly responsible for a large part of the historical emissions. So it's complicated, but nonetheless this has to be worked out somehow.